Software Engineering Radio episode 72, Erik Meijer on LINQ.
Hi everybody, welcome to another episode of Software Engineering Radio. This is Arno on the microphone, and today I'm talking to Erik Meijer about LINQ language embedded queries, and this is also part of the UPSLA podcast in preparation for the UPSLA, where Erik is going to give a talk about LINQ as well. So, Erik, how about we just start by you giving our listeners some background about yourself. Who are you? What are your areas of interest? What do you do?
All right. Well, so I'm obviously Erik Meijer, and I think since the first time one of my friends in high school tried to explain to me, that x equals x plus 1 in TRS-80 basic, didn't mean, x equals x plus 1, but x becomes x plus 1. I've been intrigued with programming languages. And, I've been on this quest to make programming accessible since then. Moving, from, I started out doing Prolog and Cecil and Miranda to Haskell. And now I'm doing Visual Basic and C#, so it's been everywhere.
That sort of sounds like you're working for Microsoft.
That's true.
Okay, so your sort of new brainchild, the thing you're working on right now, is LINQ. I heard about that. I mean, that's why we're talking here. What is LINQ? What is it about?
Okay, so LINQ is an abbreviation of a language integrated query, and the goal of LINQ is to enable easy querying and manipulation of all forms of data in any .NET language. The way we achieve that is by importing ideas from functional programming, in particular monads and monad comprehensions, to unify all the different data models. So, often people emphasize the differences between data models, like XML, SQL, objects. And so they say, they are all very different. But the trick is that if you all view them with your monadic, glasses on, they are really similar. And that allows us to define one query language that you can use to query over these different data models.
That sounds really great. Could you tell us a little more about what these common abstractions are, how you actually go about treating them all the same?
Sure, I can do that. So if you think about data, like all these data models have elements that are say in relational data are rows, and then tables are collections of these rows. If you think about XML, you have elements and attributes, and you have elements contain sequences or collections of child elements and attributes. And similarly, in objects, you have a lot of different container types like arrays and lists and so on. So all these notions of collections are very similar. And if you define a set of operators that can, say, filter and apply a function to each element of a collection and, sort collections, group the elements into partitions, all these operations are really, you can define them independently of the specific collection. In some sense, it's nothing more than using interface-based programming. So we define, a specific interface and that all these different kind of collections implement, and then the queries are defined in terms of that interface. And so really, you can view it, saying, oh, we're using all complicated mathematics. On the other hand, you can say, we're just using common sense, object-oriented principles. You define an interface, all these types implement that interface, and then you can define your functionality on top of the interface without having to know the kind of underlying implementation. Does that make sense?
Yeah, that sort of makes sense, but I'm playing devil's advocate a little. There are certain differences between, let's say, XML and SQL. XML is hierarchically structured. SQL is sort of a global data pool that you just query, where you can start at any point and sort of just follow the relations any direction. How do you sort of treat that the same?
Okay, so that is a good question. So if you look at this is, I think, one very interesting kind of, difference. So if you look at XML and objects, and now we're talking about the kind of nature of associations or relationships. So in objects and XML, relationships are kind of embedded in the kind of, source of the data, and they kind of point to the target, right? If I have, I don't know, say a binary tree, each node has pointers to subtrees. In relational data, it's kind of the other way around, right? If I have customers and orders, the orders point to the customer to which they belong. So there the relationships are kind of outside in. However, if you can map these kind of relationships, the external relationships, to internal relationships, and this is what the kind of OR mapping frameworks do for you. So you kind of bridge that gap by specifying, how a table maps to a certain class, and how this relationship that in the database goes the other way around is mapped to kind of a property or association that goes from the kind of, source to the kind of target. So that was a very good question. Now, if we're kind of speculating a little bit, one of the things that I think is very interesting is to extend object-oriented languages with this notion of external or explicit relationships. And there's, a fair number of research where people have been kind of, floating several ideas on how to do that.
Sort of treating the object as a global pool that can be treated globally, using a starting point that's sort of outside them, and using relationships that are sort of not part of the objects to relate them to each other. Is that what you're talking about?
Yes. So the powerful thing that you get there is that you don't have to define these relationships up front. So in the relational database, you can define a relationship with a LINQ table in the middle. So that means that you don't have to change the types that you relate. And I think that's very powerful, because in objects you have to kind of know up front, that you want to relate two types. And especially if you think about, like a distributed environment where you don't have control over the types that you want to relate, having this kind of notion of external relations is very powerful. But again, as I said, in most OR mapping frameworks, you kind of define your classes and you kind of bake in these kind of relationships and classes to these collections of tables. But there, you lose some of the power of the relational model, and I admit that right away. So that's kind of something I want to bring into the object-oriented languages.
Okay, but in a relational database, you have this kind of notion of foreign keys or joins. How do you generalize that to, let's say, XML?
Okay, so what is really, a foreign key, and what is, a join? So a foreign key is just, in some sense, a pointer that points from an external thing into something else. So that makes sense for kind of anything that has some form of identity, right? Because from the outside, I just have to identify the thing that I want to point to. And again, for XML, you might use the fact that maybe each node in the XML must have some kind of identity, or you can if the document has identity, you can use a combination of the document identity and some path. And then a join is in some sense in the most naive way, it's a kind of a nested loop where you're kind of checking some condition, and of course we all know how to kind of make that more efficient using indices or link tables. So the implementation of that association will use all the kind of tricks that the relational database people have developed.
So language integrated query is sort of based on this notion of having a global pool of data, and then probably this is what you were talking about called filters. You sort of filter all data by a query, by a condition. Let's say the address number is the ID of something else, that kind of thing. Is that sort of breaking it down to the concrete level? Is that what you're talking about?
Yes. So you have to kind of keep in mind that LINQ itself doesn't address this yet. So what LINQ gives you is a kind of query syntax, in the language that is defined in terms of certain set of predefined operators. Okay, and now when you're querying relational data, these queries are translated into SQL that will do the join. Okay, so that kind of works. What I was speculating about right now is, can we lift this notion of foreign keys and external relationship into the programming language? So it's kind of orthogonal. So the language integrated query gives you the syntax and operators for doing these kind of queries. The next step is to add the infrastructure, the runtime infrastructure, to do efficient joins kind of in memory.
Mm-hmm. I see. Yeah. But before we get to that, there are certain established languages for querying. I mean, select statements as part of the SQL standard, or XPath for querying XML. Is LINQ at a higher level of abstraction? In what ways does it go beyond these? I mean, I could easily imagine sort of generalizing SQL to be executable on XML data as well. So in what ways does LINQ go beyond these?
Okay, so that's a very good question. This is the kind of thing exactly what I tried to explain before. So when you look at all these different query languages like SQL, XPath, XQuery, they're all in some sense trying to do the same thing. They all have this notion of some kind of collection and operations on these collections. But each of them has a very different syntax, and it's kind of very much tied to the underlying data model. So what LINQ does is to kind of see what is common between all these query languages, and how can we abstract this commonality, and then encode that commonality in what we call the standard query operators. So if you say you could generalize SQL to work over XML, or you can generalize XQuery to work over relational data. That is kind of exactly what we do with LINQ. This is the kind of generalization. It's like, how can we generalize all these query languages, what is common in all these query languages, such that we can have one uniform query language that can, query all these different data models.
Yeah, that'd really be cool, but I still don't understand in what ways LINQ goes beyond, let's say, SQL. It should be possible to write a, let's say, cross-compiler from or cross-translate or whatever from SQL to XPath. So you could probably take the select subset of SQL and apply that to all kinds of different data sources. In what ways does LINQ go beyond that, or is LINQ just another syntax for things that select statements do anyway?
So that's kind of a little bit of a subtle question, but sure. And if you look at SQL, people compile X-query to SQL, and in some sense, or in some sense, in very real sense, we compile with LINQ to entities or LINQ to SQL. We compile LINQ queries to SQL as well. So all the kind of, in the end, the expressive power of many of these languages, is kind of the same. So I can take one language and cross-compile it into the other. But the thing is, I like to program in C# or VB, and I don't want to write SQL. I want to write this in terms of the language that I know, and in terms of objects that I know. And then these queries get compiled to SQL.
Okay. So the strength and the way in which LINQ goes beyond SQL or XPath is that it's integrated with the language, with the object and type model of the language in which it is integrated. That's an interesting point. Why don't you just tell us a little more about in what way LINQ is actually integrated with the language, with the type system of the language?
Okay, so as I said, you define for each data model that you define an implementation of this kind of common interface of these operators, what we call the standard query operators. And now in C# you can just write a query in a query syntax. That syntax is some kind of combination or mixture of SQL and SQL select, where, group by, and X-query kind of flower expressions. The compiler then translates these queries into the underlying operators. But it means that the object model that you're programming against are just .NET objects. So you're talking in terms of customers and orders, and they have strings and integers and so on. And then depending on the implementation of operators, that can take that query and then compile it to SQL. Run it on SQL Server, get back a result, a tabular result, and kind of surface these things as objects. Another implementation that we have is in XML DOM, and now you can query over that. So because you can ask, give me the children of this node, which just gives you a collection. And then you can use all the queries that work over ordinary collections on that. But you can easily imagine that you could take this query and compile it to whatever target language you have, whatever native query engine that you have that your data model kind of supports. And then map it, into objects, similar to kind of, the LINQ to SQL or LINQ to entities.
Okay, so the integration means that the output of the query is sort of types of the language or objects of the language, and that you sort of navigate using the abstractions, using the references and whatever of the language into which you are embedded right now.
Yes. But you can do, and then let me kind of go back to that later. So yes, so usually the normal case is that you use normal. You have some object that is mapped from the underlying data type, and then you just use property or field navigation to kind of move between them. But One of the things that we also have is we have special operators in the query language for doing joins. So if you want to do a join, we have queries that can do joins and that, that are implemented efficiently or can be translated into SQL joins. So even if you want to do, the more relational kind of, relationship navigation, you can also express that using a query. So you don't say customers.orders, but you say, from customers, from C in customers, join O in orders on, some expression, that relates to the foreign and primary keys. And so we allow both kind of forms of navigation.
Okay, I see. So I'm beginning to get the picture how it is sort of the generalization and the integration with the languages that adds the value. Is there any support in LINQ for writing data or modifying data in any way? Because thinking of the overall life cycle of data, querying is by far the most complex thing. But if I sort of define these relations between my type system and the underlying data, it would be nice to reuse that, to leverage that, to modify the data as well.
Yep. So we do have support for that. So, for example, if you do in-memory queries, that is taken care of by the fact that you can create objects. The LINQ to XML API allows for updating the XML DOM, so you can do destructive updates there if you want. And then for LINQ to SQL and LINQ to entities, we do support change tracking. So if you bring in objects from the database and you modify them in memory, we track the changes and then you can submit the changes back. And again, this is something that most all our frameworks have. What we don't have yet is bulk updates, or like SQL, where you can do, queries, to do updates or inserts and so on. But that's not an inherent limitation. That's kind of, relatively easy to add, but we just didn't get around to doing that. So, but there's nothing that prevents you from doing that.
Yeah, I mean, that's one area where many of the OR mappers have their weaknesses as well. So, yeah, it's easy to see how it can be generalized, but I don't think that's a big issue because, I mean, if you want to sort of do bulk things, you tend to want to optimize them some other way. But do you have...
So maybe I can say a little bit more here. So we have also support for, you can do all these things via stored procedure. So if you have a stored procedure for doing these things, you can call the stored procedures. An interesting thing that we also have, and because we have been talking about relationship navigation quite a bit, is that you can specify using a stored procedure to navigate the relationship. So you don't have to go via join. So maybe your DBA has some stored procedure that given, a customer gives its orders or, then you can use that and tell our framework to say, whenever you say customer.orders, use that stored procedure instead of kind of, generating SQL.
Okay, I see. But do you have a sort of common abstraction for modifications of data, or is that specific for the different mappings?
Yeah, so the way you kind of modify data, that is dependent on the kind of, the object context API, right? So, that is where the change tracking occurs. So we have like instance-based, updates and so on. So that's kind of specific, really to the object context, the abstraction of the database. So I would say, and not so much on the kind of query mechanism.
Okay, I see. Yeah, that makes sense. In what ways, what freedom do you have to specify the mapping between the the data model and your object model that returns the results. I mean, it's simple if the fields, if the classes have the same name as, let's say, the XML elements, and the fields of the class have the same names as the attributes of the XML. But do you have ways to sort of specify a mapping between them?
Yes. So this is, I think, in some sense, where a lot of there's so the design space there is so huge, and so for example, it ranges from some kind of default mapping where you say there's no customization at all. Tables are mapped to exact classes with exactly the same names, or you can have some kind of convention based. If the table is called customers, the class is called customer. To kind of extremely rich, complicated mappings where you can have all forms of inheritance, and you can have one table mapped to multiple types, or one type to be split into multiple tables. So there's a kind of very, very wide range of possibilities there, and we have at least kind of two. It's like linked to SQL, which is based on relational data. And there's linked to entities, which is based on the entity data model, like entity relationship model. So that's kind of that allows you to do more richer mappings. But again, I think the design space there is enormous on how to specify that.
Yeah, that's definitely so. Is there a specific syntax for that, or is it an API? How is LINQ sort of structured internally? Is it sort of like a language? I mean, we're talking about different mappings. That sort of sounds like there is an API abstraction where you sort of plug in. So what's the architecture of LINQ?
Yeah, so again, you have to kind of make a little bit of a distinction between LINQ, the kind of core LINQ, which is the sequence operators plus the query syntax, and then the specific kind of APIs that interface with a particular database or data model. And it's usually the kind of mapping is kind of specific to that API or to that data model, and that is, that's kind of orthogonal to the query syntax and query operators. But usually the way the mapping is done, I mean, I think most OR frameworks use something similar. It's like, again, it ranges from just inferring this thing from the types, or putting custom attributes, or in Java terms annotations on the classes, or having some kind of external XML file that specifies that mapping. But as I said, the whole notion of mapping is in some sense orthogonal to kind of the core of LINQ.
Yeah, but so is from the perspective of LINQ, is the mapping just an API that you sort of need to provide an implementation for, or is there a sort of default syntax to provide the mapping?
And again, this is a hard question to answer, because so like your LINQ itself doesn't say anything about that. So what LINQ gives you is in C# and VB, it gives you particular query syntax, and it specifies this set of standard query operators that that is the target of these queries. Now, you can imagine that using these primitives, people build several frameworks that use these queries and the expression trees generated by these queries to interface with, an external database or an external data source. And it's these APIs that kind of, where this mapping is specified. Because that's where, that's the kind of boundary between the object world and the, the external data model world.
So this whole issue of mapping is sort of outside the LINQ core, and it's up to the providers of the plugins for the specific data implementations.
Yes, exactly, and that I think is the beauty of LINQ, is that it's really in some sense a very general framework that we give you, and then it's one way to look at it is like a meta-programming framework. So it allows you to specify queries in the programming language, and then we hand to your API. We can hand a representation of those queries, and then you do whatever you want with it, and that's probably parameterized by some mapping that you do whatever you want with. So that's the kind of power, right? So it's not that is not hardwired. It's really kind of a general purpose framework for dealing with data and with all forms of data. So that's the nice thing about it, I think. And we're not tied down to XML or SQL and some particular mapping format.
One of the things that is sort of hard to implement when you write an OR mapper, and is really powerful when you use an OR mapper, is lazy loading with all the different kinds of optimizations for prefetching and that kind of thing. Is there any support for that in LINQ, or it sounds like that's probably up to the implementation of the actual data format plugin as well? Is it like that?
Yes, exactly. So let me give you a specific example of that. So, for example, LINQ to SQL allows both eager and lazy loading. And that is again, that's something that's specified, as you said, exactly by the LINQ to SQL API, and that kind of takes care of that. When you write a query, that you're not reversing a eagerly loaded or lazily loaded relationship in a different way. It is, the underlying infrastructure that takes care of that. And again, that will then, has to make sure that, all the stuff gets implemented efficiently.
What mappings does LINQ come with? I mean, if you use Visual Studio, what mappings do you get out of the box without having to write them yourselves? Okay,
so out of the box you get LINQ to objects, which is just the query operators defined for in-memory objects and collections. In this case, IEnumerable. That's like in Java, that's iterator, so that's kind of lazy collections. Second one that it comes with is LINQ to XML. So this is another kind of XML DOM that is designed specifically to kind of fit well with LINQ, to fit well with the query operators. Then there's a LINQ to SQL, which is the kind of OR mapper that kind of goes directly to a SQL server. And then there's a LINQ to entities, which uses the entity data model. And people are, if you look, if you search around on the web, you will see that people are doing all kind of interesting things there as well. So people are doing, LINQ to Amazon, LINQ to the registry, LINQ to SharePoint. And again, this shows the power where, we give the framework and then people kind of build their own kind of layers that interface with some external data source.
Okay, so let's say I want to start a LINQ project. What sort of roles should I plan for people to sort of interact with LINQ, and how should I go about integrating LINQ into a, let's say, large application for, let's say, large banking application, where people sort of, where the teller enters data and goes back to the database, the usual thing. how would I go about integrating, or what roles should I plan for? What needs to be done?
Okay, so the first thing that you need to decide is which mapping or OR kind of framework you choose. So that's kind of maybe I think probably if you're in a large enterprise there will be some kind of, usually people have already kind of some kind of OR framework there. So imagine that's the kind of the more interesting case in some sense, in which case you have to kind of implement your own kind of interface with the LINQ queries to do that.
So okay, so let's say I sort of have a relational database, but there are some specifics that go beyond what is there out of the box.
So I'm not sure what your question is, but let's say that you want to take something out of the box, right? And let's say that you want to do something kind of relatively simple. You want to interface with straight relational data. Okay, just nothing,
Yeah, exactly. That's what I meant. Yeah.
Okay. So that's a kind of, that is a scenario that's kind of, supported out of the box. In that case, you probably would use LINQ to SQL. And what you would do is there's several tools, there's a kind of, designer tools where you import your database and you kind of define the mapping between your tables and your classes. And once you have done that, now you can, and so maybe, as I said, maybe your database uses stored procedures, and again, the tools and the framework allow you to kind of, bind stored procedures to these queries. So I can tell, to use stored procedures to navigate a certain relationship. You specify which things are loaded lazily or eagerly, and then once you have done that, it's just a matter of writing C# or Visual Basic code using these queries. And in some sense, that's actually very much the same if you would use LINQ to entities. There, again, you would specify the mapping between your database and your objects, and from there on, you just write queries in C# or VB. These queries, the result of that query is some piece of SQL that gets executed on the server. The results come back, and then they're materialized as objects. So it's, but the nice thing is that, let's say if we compare it to the way you do things today, say you use, data sets or something like that, there you would have to, write SQL as strings that you pass to an API, right? So you would kind of, open a connection, then you have to create a SQL command that you do by, putting some SQL string that you pass to the API. Then you get back the results as, kind of untyped tables. And so you're not, you're not programming in terms of, your objects, plus that you don't get any kind of, intelligence or checking of the actual query.
Mm-hmm.
And this is the big advantage is that when you use LINQ, your queries are statically typed, so you get full intelligence and type checking, such that you never try to get the hair color of a customer when the customer doesn't have a hair color property.
Yeah, I see. So that's the integration part again, enhanced with IDE support and static typing.
Yep.
To what degree would you say does LINQ scale sorts of, let's say, huge applications of thousands of classes, tens of thousands of classes, and when I was talking about scalability, I mean maintainability for large projects. It sounds like a great way to get started quickly, to get first results very easily, very quickly, and it's easy for me to believe that it's great at that. Do you have any experience or any sort of estimate for large applications, or is it more targeted at the small and simple applications?
So let me kind of try to answer this question, without sounding, fake. So there is an interesting, if you look on the web, one of the performance architects here in the CLR has in his blog, stuff about the performance of LINQ to SQL. And the thing is that if you compare it to, say, you have to write a complex query by hand, right? So you're using just old-fashioned data set or ADO.NET, and you have to write a complicated query that involves joins and whatever. The chances that you write that SQL by hand in an optimal way, compared to what our compiler can do, is kind of I think letting the compiler do that is usually a better bet. But on the other hand, if you encapsulate that query using a stored procedure, say there's some specialist that really knows how to write this optimal stuff, you can use that too. Or we even allow you to kind of, if that's what you want, to still kind of bypass the whole thing and use SQL directly. So the thing is that I think intrinsically, in some sense, anything you could do before, you can still do. And we're trying to make it easier to do what you did before. But so let me answer the question like this: if you could write, your applications before using, ADO.NET and dataset and so on, or data reader, you can still, those applications will still work. I cannot kind of, say in general, it's like we're not taking anything away, so to speak. So there's nothing intrinsically there that, stands in your way. It's just kind of taking away the noise that you would have to deal with, writing SQL queries by hand.
Okay, I see. I was sort of looking at from a different perspective compared to, let's say, full-blown OR mappers like nhibernate or something that have sort of evolved over years, have been used for huge projects, and sort of are targeted at maintainability and are sort of more specialized, they're less general, but, well, I would expect it to be easier to write a full-blown OR mapper that is a little better at OR mapping than the LINQ approach that is sort of generalizes the data model. So that was the comparison I had in mind when I asked about this scalability in terms of maintainability for large projects.
Okay, so I can answer that. So as I said, right, you really have to separate the kind of, the OR mapper and that whole infrastructure from the core LINQ. And so, and I'm pretty sure that if somebody is already doing it, is to take nhibernate and have, a LINQ, part on top of it, such that, you can query that by using LINQ queries.
Okay, I see. So yeah, that makes sense. So sort of beside the point, because the LINQ is sort of a query interface that can be plugged on top of an arbitrary OR mapper. Yeah, I see that.
Exactly, and that's kind of what I like so much about it, right? Because there will be, imagine that at some point, I don't know, you come out with your own kind of, special database, whatever. You want to be able to kind of query that from a nice way from VB and C#. So that's, that's the kind of thing that's supported by the language, our languages and the kind of standard library. And then we allow you to kind of write that layer that kind of then interfaces to the kind of standard sequence operators and query syntax.
Okay, yeah, I think I got the idea. So I think I sort of got the big picture, got the overview of LINQ. Would you like to add anything? Is there anything you think that should be added talking about LINQ? Anything we missed so far?
That we talked about here. So one of the things that's kind of interesting, and when we talked about like relational data in the beginning, one of the interesting things is if you look in relational data is kind of flat, right? It's never nested. So for example, that means that in SQL, whenever you do an aggregation, you immediately have to do, so whenever you do a grouping, you immediately have to do an aggregation, right? Because the results that you return have to be flat. But conceptually, if you want to think about your problem, it's often easier to think, well, I group my data, now I have collections that each have collections, which are the little groups, and then maybe, I group them recursively again, and then, you aggregate over them. So having a general data model that allows arbitrary nesting, I think makes it easier for people to kind of think about their queries. And then, we can take, a query that's defined in terms of this kind of arbitrary nesting and compile it to SQL, which, is still, we just kind of compile that to SQL where it's still run using the standard SQL operators. And for instance, if you want to have a hierarchy, often you have to do, if you want to return a hierarchical result, you have to do two queries, right? And then, have to reconstruct the hierarchy, on the way back. All of these things are pretty hard to do by hand. And whereas if you do this using the tools and rely on the compiler that takes the query expressions and compiles them to SQL, all these things become a lot easier.
Yeah, I see. Yeah, that's certainly true.
And I think that is one of the nice things of having this kind of, more abstract data model that kind of, generalizes each of these, is that it's kind of very compositional. You can think, you can break up your queries in little pieces and understand them kind of, all by themselves and then kind of hook them up together. Whereas often in SQL, you have to have this query that's kind of, some kind of monolithic query, right? You have to say from, select, group by.
That's especially combined with the support in the IDE. That's certainly a very, very huge point. That's true.
And then the other thing is that I think, one thing that we haven't really discussed, but which is, I think, very, very cool, is the notion of expression trees. So, and I kind of, mentioned this between the lines a couple of times, but one of the implementations of the standard query operators that I mentioned, this interface, right, in which the queries are defined, one of the implementation of that takes, expression trees that represent delegates, that represent, say, you're doing a filter where, so you pass a predicate, the filter predicate.
Mm-hmm.
So what LINQ allows you to do is to get that predicate as an expression tree. So it's, say, the kind of abstract syntax tree that represents that delegate. And so that gives you kind of a meta-programming ability. So instead of having, representing your program as strings, what often, as I said, like, SQL APIs have where you pass the SQL query as a string, or a lot of XML APIs too, right? Take XPath expressions as strings. But now, the compiler will insert all the stuff to kind of create these expression trees, and then, so this is a much higher level of abstraction than this unstructured string. And I think, there's a lot of opportunity to use these expression trees outside queries in particular. I mean, we talked a lot about, like OR mapping and so on, but imagine, there's interesting research in Microsoft Research here that uses, your GPU, which is like a parallel, data parallel machine. And what you can do is you can now take some computation over, some kind of array of floating point numbers or something expressed in LINQ, and instead of compiling it to SQL, you compile it to the instructions of your GPU, in your graphics card. So again, that's why, it's like LINQ is a very, very general mechanism that in some sense it's independent of relational data. So you can use it to run on your GPU. And if you like F#, Don Syme has a very nice example of doing that, in F#, where he uses the LINQ expression trees to kind of do that. And as I said, I think this is just the tip of the iceberg when people start to discover this kind of metaprogramming. And this has been, of course, existed in Lisp and Scheme for ages, right? For 50 years, I don't know how long. But now we put this in these kind of mainstream languages, and once people start to discover that, I think interesting things can happen. So I just want to stress that LINQ, it's really this general framework for expressing queries based on some kind of common interface, and then it's everybody can provide an implementation of these operators, and that may have nothing to do with relational data.
Mm-hmm. Yes. Well, thank you very much.
All right.
Nice talking to you. Quite interesting. I think we have a lot better understanding about how to query data now. Thank you very much, and see you at UPSLA.
All right. Thank you very much. Bye-bye.
Bye.
Thanks for listening to Software Engineering Radio. If you want to get more information about Software Engineering Radio, or if you want to give us feedback, please go to our website at se-radio.net. You can also contact the team at team@se-radio.net, although we prefer entries in our comments system on the website so other people can see what you think. Software Engineering Radio wants to thank Henning Pauli for the intro and outro music, as well as Libsyn for providing the bandwidth. This episode of SE Radio, as well as all other episodes, is licensed under Creative Commons license. See the Software Engineering Radio website for details.